Okay, we'll continue our discussion on the packaging integrity testing methods of different kind. So another method we're going to talk about is called a helium mass spectrometry method. So as this diagram shows, your packaging material is hooked up with the helium gas, okay, and then that will be placed inside of a vacuum chamber. And then, so any leakage of the helium gas will be detected in this vacuum chamber when you're pulling the vacuum. Okay, so if there's any opening or leakage, the helium will travel from inside of the packaging material to outside, and that leaking helium gas will be detected through the mass spectrophotometer. So that's how this method can detect the leakage of the packaging material. Okay. Another method will be microbial challenge test. Okay, so the container is filled with growth medium or product or closed container, and that is immersed in maybe solution filled with bacterial cells. Of course, if there's any leakage, bacterial cells will love to grow in those, so you can detect the leakage of your packaging material, because there will be evidence of bacterial growth through your packaging materials. So the rack contained packages in there, vent holes and shakers, nicely shaken up, and outside it has a contaminated water that has some bacterial cells inside. So you can have, if the cells can go into your packaging material, so your packaging will be inside integrity will be contaminated or not. So that's how this testing will measure the leakage or damage on your packaging material. Next test is called the vacuum decay leak test. Vacuum decay leak test. Again, this diagram shows you how it works. So your packaging material, and of course there's a pressure gauge installed, and it will be filled, and then vacuum will be pulled. So this is a non-destructive test, where this one is destructive test, of course. This one is destructive test as well, but this one is non-destructive test. So understand which one is destructive, which one is non-destructive. So this one would be non-destructive testing. So the package is placed in a test chamber, okay, and the chamber is closed, and vacuum is rapidly drawn to a target pressure. After establishing vacuum and its subsequent pressure rise, if there's a pressure rise, that means that's due to the leakage of the packaging. So that we consider as a vacuum decay inside of the testing chamber is observed. So that's how you can detect the leakage of the packaging material. And the next, those are all the packaging testing methods that are out there and they used frequently. So how many did we talk about? 1, vacuum decay leak test. 2, microbial challenge test. 3, helium mass spectrometry. 4, frequency modulation spectroscopy. And then 5, electrical conductivity testing. And 6, diode liquid tracer testing. And 7, which is the bubble test. Okay, so 7 different methods that you can use to test the integrity of your packaging material. All right, 7. Okay, and then we'll talk about the stability, storage, and distribution of sterile product. Of course, product stability is really important. During the shelf life period, your product should be stable, and they should be preserved the efficacy of your drug, right? So many injectable and ophthalmic drugs exist in solution or dispersed system. Talked about dispersed system, right? Suspension drugs, emergent drugs, and gels and things like that. So they are more prone to chemical and physical degradation mechanisms like hydrolysis, oxidation, and physical deterioration like protein aggregation and particle formations. So you need to make sure that their integrity, their structure is maintained during the shelf life period. Okay, so GMP state 2 main requirements with respect to stability testing. Okay, according to CFR 211-155, requirement for a written testing program designed to assess the stability characteristics of drug products, which is used in determining appropriate storage conditions and expiration dates. Okay, the next one is CFR 211 point 167. It says requirement for an adequate number of batches of each drug product to be tested to determine an expiration date, and such date to be maintained. Okay, so there's a heavy burden of stability testing and validation. Okay, so basic requirements for design and interpretation of stability studies for finished dosage forms are like this. When you start to manufacture the first 3 batches, okay, 2 of which are pilot plant scale, and 10% size of the commercial scale, okay, they represent the marketed formulation, package, and validated product processing are used in stability testing. So when you start manufacturing your product, the first 3 batches should be used for your stability testing. That's what it means. Okay. When you do your stability testing, it's a long-term study because during the long storage time, the stability of your drug should be maintained, right? There's a long-term testing that should be done. The long-term is normally about a 1-year period. 12-month stability testing data should be generated, okay? So this testing should be done before you submit your regulatory, NDA, new drug application. So it should be part of that NDA form. So normally that long-term study is done at the room temperature, 25 degrees Celsius, plus minus 2, of course. And then humidity level is about 60 and plus minus 5% humidity level. Okay. And if you don't want to do it like a 12-month period, you can accelerate that testing at a kind of harsher condition, which means it's only like a 6 months period instead of 12 months, half a year. But the temperature should be raised to 40 degrees, plus minus 2, of course. And then humidity is also raised to 75%, plus minus 5. Okay, and that's if you expose your drug under that condition, which is much higher, more challenging, then you can do that in maybe half a year period, a 6-month period. Okay, that's considered as accelerated testing. But not many drugs can go through 40-degree, temperature condition at the higher humidity. So I don't know. It depends. If your drug can withstand that, you could try that. But if not, you cannot. Also there are some drugs that should be refrigerated or frozen all the time. Then you cannot use those conditions, of course. And if significant change happens during the accelerated study, then instead of using that condition, you can use something called intermediate condition. Okay, that is a little milder. It's about 30 degree plus minus 2 temperature, and then 60 plus minus 5%, the same humidity level, but the temperature is raised to about 5 degrees higher. Okay, so intermediate condition can be used. So 6-month testing frequency in the first year and the 6 months in the second year. The 3 months. So during the first year, every 3 months you do the testing. That's what it means. And the second year, you do the testing just every 6 months. Okay. And your drug may be receptible to the strong light. That's what this means. Photostability is your drug stable to the strong light condition, or physical condition, or chemical condition, biological or microbiological condition. All those things should be tested. Okay, and preservatives, if they are added in your formulation, should be also tested. We talked about preservative testing before, right? PET test. And then product packaged in syringe and cartridges should be tested for functionality. I mean, during maybe 6 months time or 1 year time, your syringe and cartridge should be remaining intact as well. Okay, and then they should still perform their job, design the function. And stability studies will include a justifiable small sampling method, sampling plan. Okay, so to assure unbiased selection of samples. So 2 samples per each sampling at maybe 0 time, after month, 3 months, 6 months, 12 months, 18 months, 24 months interval, or something like that. That could be example. Okay. And then how do you determine the expiration date for your drug? Okay. Expiration date is based on the best fit line regression analysis of real-time stability data. So your expiration date is based on your stability data, and at the one side lower 95% confidence at time point. So what that means is, if you look at this graph, there's like 100%. It's like good. Your drug is still 100% active and effective, right? But there's a time when your drug, so if you did so many testing, it could be an average of all those testing, but whatever that is, from maybe 100%, your efficacy may drop down to maybe 95%. Okay, it's that time will be given as your expiration date. So if that is about 33 days, that should be the expiration date for your drug. Okay, so that's what your expiration date determination method is. Okay, so after reconstitution of freeze-dried product, if we are dealing with the freeze-dried products, okay, then what kind of stability study is needed? So the standard stability period is 24 hours at room temperature. That's after reconstitution is done. Reconstitution means what? If you freeze-dried drug, it should be reconstituted with the UFI before you give the injection, right? Once you reconstitute it, is your drug still active and then maintained at good efficacy? That's what it means. Room temperature for about 1 day, 24 hours, your drug should be still good. Okay, but if it's refrigerated, at least at 2 days, your drug should be still good. That's the requirement, okay, for your freeze-dried drug. Okay, and many drugs are sensitive to light, of course, and data on the light stability should be also collected at least one primary batch of the drug product. So it should be tested how much effect the light has. Okay, and unprotected bulk drug, fully exposed drug product, and the drug product in marketed package are all to be stress tested for light stability. Maybe exposing a drug to the strong light and see how damaged your drug is. Okay, if unstable, the product should be adequately protected from exposure to light. How do you do that? By maybe packaging a brown bottle and things like that. Okay. So then how do you do the light testing? It's exposure requirement for the light testing. Stress test is about 1.2 million lux hour or above. Okay, or that's like by near UV light energy, very strong light energy exposure. That's what it is, above like 200 watts hour per square meter. Very strong intensive light. It will be exposed to your drug. That equals to about 5 months exposure under normal room light for 10 hours a day. So that's the stress testing. So very strong light conditioning exposing your drug. After the first initial products are stability tested, 1 lot per year of each dosage form and container closure system of the product is placed on a long-term stability test. So your stability test is continuing. That's what it means. And then whenever changes of deviation happens, special stability testing should be conducted following that. Okay. So storage requirement for drug products in semi-permeable and impermeable containers. Okay, if your drug is packaged in the impermeable, semi-permeable containers, and you need to store them, certain conditions like this. If it's a long term, you can do the room temperature ±2 degrees Celsius and 40% ±5 room humidity level. Okay, and then if it's accelerated condition, you can do the 6 months instead of 12 months. That's 40 degree ±2, 75% humidity. If it's an intermediate study, same 6 months, but it's a little lower. Better conditions, 30 ±2 and 65 ±5. Okay, but if your drug can be kept in the room temperature, if that's the storage condition. But if your drug should be kept in the refrigerator, then long-term study will be the refrigerator condition, 5 ±3, and monitoring the room temperature, the humidity level. And if that's going to be accelerated, it's going to be room temperature instead of a refrigerator condition. That's only 6 months. If your drug should be frozen, and it's going to be -20 degree, okay, ±5. But if it's accelerated instead of freezer, you can create a refrigeration condition and you test it there, ambient humidity. So that's the testing condition for the storage and the efficacy of the drug. Okay, make sense?